welcome to the latest installment in our UXDX online series. I hope you're as excited as I am for the talk we have coming up today, but before we jump into that, I want to give a very quick introduction to UXDX and why we host these sessions. So at UXDX, we always say the world is full of bad software. And I don't mean that by buggy software or software that doesn't work. What I mean is software that doesn't meet the needs of the customers. And there's research that says that 90% of the products we're building, customers just kind of go, meh. And I always use the example of banking. I have a very traditional bank, as well as one of those new digital first banks. And while the apps technically do the same thing, they're worlds apart in terms of usability and which one, therefore, I reach for and do more business with. Now, our mission is to help companies build an environment that can't build bad software. Now, why we say that is because I don't think it's down to the people or the motivation or the skills. I think it's the environments that people are working in that result in those clunky or difficult to use applications. So our mission is to help teams build that environment that can't build bad software. And how we do that is by helping companies shift from waterfall projects where everything's designed months ahead up front to truly iterative product teams where teams are empowered to learn and iterate based on feedback from customers. Now that's really easy to say and incredibly difficult to do in practice. So that's where these talks come in. Now every week we ask people to share how they're changing their ways of working. So nobody's going to talk about the entire end-to-end workflow, but we ask people to say how are they adopting new technologies or new processes, and hopefully you can learn from that. And that's where the questions come in. So at the end of the talk, there'll be a few minutes for Q&A. So please do write your questions in, and if you get them in there early, chances are it will be the first question asked. So without further ado, you're not here to listen to me speak. So I'd like to introduce our speaker today, who is Rustam, who will be talking about building a multilingual content pipeline with Whisper, GPT-5, and TTS. So I know kind of everything AI is the topic of the day, so I'm really excited for this. So I'd like to welcome Rustam to the stage. Over to you, Rustam.
Hi everyone. Yes, my name is Rustam, and we will be talking today about the podcast localizations. So, in short, this is when you take a podcast in some language, typically this is English, and translate it to some other language, to your native language, for example. In my case, this is Russian, and you use OpenAI's tools for this, and especially you use Whisper, GPT-5, and TTS. And today I will be sharing how we are doing this, the short introduction to the process, and I will also show you how it all looks in the code and how it works step by step. So we will start with with a quick presentation. It will take about 10 minutes, and then we will go to the code itself. So the very first question is, why do we even need it? And the first main answer to this question is to make content accessible to a wider audience. So if, for example, you are not an English speaker, but I don't know, Mandarin or something else, you can just take your podcast and translate it to some other languages and publish it on your favorite platforms so that people who don't know Mandarin will be able to listen to your podcast. So this is for creators first. Um, Second thing is that if you mm, if you use products like this, you can always make it try at least to make it sound humanly. You can make it sound with emotions, like it's your main language, but it's actually not. So you use um, you try to add audio with emotions, and people are uh, mm, not listening it as just an audiobook with no emotions at all, but as a real speech. And the third reason to do this in a programmatic way is to reduce manual effort. So you don't need to translate anything at all. It just really takes about a few minutes to translate a whole podcast, which is usually about 40 minutes long, into a podcast on another language. Um, so core features that we have in a project is a first podcast downloader. In our case, we take a library of podcasts in English, and we download audios and some information from there to further translate it to our target language. In our case, again, this is Russian. Second step is transcription. We take this audio file and transcribe it. And after this stage, we will have a text file with all the content spoken in this episode. Um, Third stage is text processing. So we take the text which we generated on the second stage and we process it. And by processing, I mean we remove some unfinished sentences, we combine some sentences into one sentence. Um, we can drop some words which are not really needed, because when you speak you use a lot of words without any meaning just to fill the empty space, and you don't want to have it in the final result. So we have this and some other things in the text processing stage. Then we have speech synthesis. This is actually the moment when we use TTS1 model, text to speech model, which takes some text and generates voice over this text. And this will be the final podcast, the final audio file, I would say, but it can be a podcast. Then the fifth stage is audio assembly, when you take multiple audio files and combine them together. I will talk about this later, why we even need this stage. And the last one is RSS generation. And this is, well, RSS is basically a feed of all the podcasts that you have, and you publish them onto platforms like Apple Music or Amazon, something where you have all these podcasts. And it's basically just an XML file where you list all your episodes, and these services go to you and fetch these episodes from time to time. And if they see that you have new episodes, they will add it to their platform. So we also need this stage. The key technologies we use is Kotlin as the main language for our project. Um, Kotlin, if you are not familiar with it, it's kind of like Python and Java. From Python, it took the syntax, it's pretty similar. And from Java, it took everything else, including the speed of execution, type safety, all the runtime features, everything. So it's a JVM language with Python-like syntax. Podcast4j is a library which we use to fetch podcasts from podcastindex.org, which is a library of podcasts. OpenAI API is the magic that we use. So we use three things there. We use GPT-5 for, um, for example, translating the text or for improving the text, which we took from the audio file. Then before that, we take text from audio file, we transcribe it using another OpenAI model, Whisper model, and then we generate a new audio file using TTS model. Then we use OkHTTP for HTTP requests. We need it for sound libraries because they kind of provide a way to interact with services. For example, OpenAI ASDK doesn't use any particular HTTP library. We can use whatever we want, and we use OkHTTP there. Jackson to work with JSON data, and we use JSON data for all the intermediate steps when we, for example, save information about the podcast, such as title, description, authors, anything else. We save it in a JSON file, and also we save there a link to the audio file if we have any, a link to the thumbnail of a podcast or of an episode. We sometimes have this, and for any other JSON data. XML API, we only use it for building RSS feeds. We use just the one which Java has embedded, and we use FFmpeg. We'll use FFmpeg in future to merge multiple audio files. Again, I will tell about merging audio files a bit later, maybe even in the end, because it's not that important here. So the very first stage is fetching podcast metadata in audio. We use this podcast4j library and fetch information from podcastindex.org, information about some episode of a podcast. So we will fetch title, description, authors, anything else, publish date, and then download the MP3 file itself. Then we will transcribe the text, the audio file, and we will use Whisper1 API for this. And remember when I was talking about like merging files, this is the very first reason for that merging is because we need to split these files first, because Whisper doesn't work with very large files. And if you have a podcast which lasts for 2 hours, for example, it might be bigger than 25 megabytes, and you have to split it first into chunks of less than 25 megabytes, feed it into Whisper, and then combine all the text, or work on every part separately and then combine audio files together. This we will see in the code examples. Some challenges that we have here is that we have limited voice options. We do not have a lot of different voices, and we use a voice with slight American accent, so that it's when you listen to it, and the original podcast was in English, you hear it as a podcast with slight American accent, so you understand it's not native Russian or native some other language which you are translating into, and you understand that this is somehow was translated using a tool, not a manual translation. This is not interesting. I will share the whole presentation with you after we finish. We don't need this. Blue scores, also a nice thing. We currently do not use it, but we are planning to add it soon. So in short, this is a methodics quantitative measure of translation accuracy. And in short, it says for a given English text, and for example, Russian text translated from this English, how good it is. And it gives you a numerical value, and if it's lower than some threshold, we can say this is not acceptable, and we have to check under the hood. We have to check what we have as a translation, what we have as a source. We can fix the prompts and so on. So this is a very easy way to understand if your translation is bad. It's not guaranteeing that your translation is good, but if it's bad, it will catch it. Code snippets, we don't need it right now. I will show you again a bit later. And publishing also is not that important here. Let's I will share you my my IDE, and I will show you how it all works. Just give me a second. Okay, here we go. Okay, let's go into the code itself. I will show you the main part here. We have, let me get it a bit bigger for you to read everything easier. Um, okay, um, let's go this way. Um, I hope you see the code. And what we will do here is I will show you some prompts first. Um, here, we have few prompts here. First prompt is improve transcription when we have a transcription. And it says, I have a transcription of a podcast in source language, which will be English in our case, and I want to improve it. Add missing commas, quotes, and fix incomplete sentences. Output only result in text. And we give it a transcription. And the other thing is I have a transcription of a podcast in English, translate the text to some other language, target language, in our case Russian, or we can use another language if we want to. Keep the tone of the speech the same, and we give it the transcription. Let me let you listen to the original file that we will work on.
This is episode 2 of What's in a Name. In the previous episode, we learned how scientists name species and the controversies that can result from those names. But names don't just matter to scientists, they can impact all of us. In this episode, we're moving out of the universities and scientific publications where names are chosen and into the public realm where names chosen by scientists meet non-scientists.
This is our first part of the episode that we will working on. So I have it in the file English intro here, and in speech to text, this is the transcription of what we have just heard. So I will read it for you. This is episode 2 of What's in a Name. In the previous episode, we learned how scientists name species and the controversies that can result from those names. But names don't just matter to scientists, they can impact all of us. In this episode, we're moving out of the universities and scientific publications where names are chosen and into the public realm, where names chosen by scientists meet non-scientists. As you can see, this is pretty much perfect transcription of what we just heard. And this is made by the Whisper model. I will show you how we do this. So we have this process file function, which takes a file audio path to the file with the MP3 track of the podcast. We have source language, target language. We only use source language for this purpose, for transcription. And the first step is transcription here. So we take this file and we will save it to another file with suffix speech to text. And on the left, you can see files here. We have English intro and speech to text file, which I just showed you. And to actually get it, we call transcribe audio, which sends the request to the model Whisper1, uses this audio file. The Whisper1 model transcribes it, returns it, and we have it as transcription. It has some properties, but we only using text here. It also has language, duration, words, segments, whatever it is, but we are only using text from it. So we have text, Now we saved it into our speech-to-text file, and that's it. The next stage is stage 1, improvements. We try to improve this transcription, and to improve transcription, we use OpenAI prompt improve transcription function, which I showed you before, and this tries to add missing commas, quotes, and fix incomplete sentences. We do this. We send this request to a model GPT-5. We can also use GPT-4o. It's just cheaper and faster, but for better results, you have to use the newest models, in our case, GPT-5. And you say, well, you have a role system, and you send this prompt, which says remove commas, fix sentences, and so on. You get a response, and this way you can take the content of the response, which you got from the ChatGPT. After this, you have it in a file with the suffix one improved speech to text. You have it here. This is episode 2 of What's in a Name. In the previous, well, you will see that you have this all these punctuation marks. You will have some missed commas here, and so on. Next stage is we try to translate it, and we do exactly the same. Translate preserve style function takes uses this prompt. I have a transcription of a podcast in this language, translate it, give the tone and speech the same, and it returns us the text of a podcast in a new language. Again, it's absolutely the same as we have just seen. It returns this text and saves it to translated speech to text. We have it here. It's in Russian. It says, это второй выпуск подкаста «Что в имени?». В предыдущем выпуске мы узнали, как ученые называют виды и о спорах, к которым эти названия могут приводить. Но имена важны не только для ученых, они затрагивают всех нас. В этом выпуске мы выходим за пределы университетов и научных публикаций, где выбирают названия, и переносимся в публичное пространство, где названия, выбранные учеными, встречаются с широкой публикой. We have this text. Again, we can use any language we want for this. And then stage 3 is running the TTS model, text-to-speech model. And again, we will save it to suffix 3 tts.mp3. We call text-to-speech, and it splits first all our text into chunks. And for us, chunks are, so TTS has a limit of 4,098 characters, and we take the parts in this transcription and split it into parts no longer than 4,098 characters, and we split it by whole sentences. So we have multiple sentences. We translate, we generate speech for every part of it. So we take the MP3 file, we save it into this chunk index MP3. Here on the left, you can see the file which we generated, and we will put it into result, and then we will just merge all the parts, so we have our final podcast in a single file. And that's it. That's all we have. That's all we do. And let me just remove this and run it in real time so you can see how fast it is. It's running, so it's just started. Transcription finished. We run improvements using GPT-5 model, and it's working only with the text, which is, I don't know, like 410 characters. It's about 200 words. Transcription GPT-5 is working. we are just waiting for the response from them. Today, for some reason, it's pretty slow. So we finished the improvements. Now we run translation uh, part. Translation also takes about the same time, and it uses GPT-5. TTS uses TTS1 model. We don't want to listen to it right now. And so we have our MP3 file just here. That's it. So it took us approximately 30 seconds to translate a podcast, which a part of a podcast which lasts for 30 seconds. If we use GPT-4o, for example, it will be much, much faster. It will be a bit worse in quality, but much faster. So, for example, for a podcast which lasts for half an hour, you can spend 3 minutes translating it using this tool into some other language. So I think that's it. If you have any questions, please ask me. Um, yep, that's how we do the podcast translations.
Excellent. Thank you very much for sharing. That's actually, it was great seeing the real live demo, and I think OpenAI just did their Dev Day demo, so I've noticed it's very slow today as well. They've just
Yeah,
announced a load of new features that people are probably testing out as we speak.
yeah,
Um,
that's the reason.
Great. So yeah, I've got a couple of questions on that. Because you're hitting the OpenAI API quite a few times, like the initial translation, the second validation, the all of those. What's the cost for, let's say, a 30-minute podcast? How much is that costing your API?
We can actually check how much we just spent, but in average, I think for a 40 minutes long podcast, it's about like 50 cents, I guess, stuff like
Okay,
that.
so it's very reasonable cost. It's not
Yeah,
going to break the bank. And,
which
and have you, like, I know you were explaining the quality difference between like a GPT 4.0 and 5. Have you tried any of like the Llama or other open source GPT? OpenAI have released some open source ones that maybe you could run locally, or it's just not worth the effort because of the price isn't high enough.
yeah, we haven't tried it, so I can't really speak about it. We tried GPT-4, GPT-4o, and GPT-5, and I can say for sure that GPT-4 and 4o are much, much faster right now. So if, for example, this in this case, it took us about 30 seconds to do all this stuff. With GPT-4o, I was testing just an hour ago. It took, I don't know, like 7 to 10 seconds, maybe. And quality was a bit lower, but just a bit.
Okay. And you mentioned actually, and I thought it was really interesting that test that you talked about during the presentation at the start. I think it was Blue, BLEU.
Yes, yes, this is a mathematical model. I'm not sure exactly how it works. We're looking at the library which takes two texts, English and the translation, and runs some magic inside it, and then says you the score.
Okay, is that another API that you're hitting, or is that something you just run locally?
It's running locally, yeah.
Okay,
Yeah, this is a
uh,
mathematical model, so you don't need a service for it.
brilliant. I might look into that because it sounds quite promising.
Yeah.
Um, yeah, I think that actually brings us to time. We're just almost hitting the half an hour now, but I found that really interesting. It's great to see how people are kind of tacking on multiple of these kind of API calls to turn it almost into a product. And yeah, I think it's quite interesting where you'll go with that. You've now got an audio in a different language and the content to create some blog articles or something like that.
Yeah, this is pretty interesting. And also for creators, I think this might bring a lot of new listeners to people who publish their podcasts or their stuff not in English but in their native language, and then English-speaking people can just listen to it. That's nice, I guess.
And sorry, I guess last one. Have you looked at? I think it's Synthesia or HeyGen. They are tools that literally convert video, but I think they change your mouth as well, so it looks like you're speaking the foreign language.
Yeah, I saw this stuff. It's very interesting. I think we can also try using them. We can probably even try
They
not
are
just
expensive.
yes, not just audio podcasts, but also video ones. That might be really interesting. Yeah,
Yeah.
that's cool technology.
All right. Well, thank you once again, Rustam, for sharing. I hope you had some fun. I hope everybody out there enjoyed it as well.
Yeah, thank you. Thank you very much for having me. Thanks.
So that brings us to an end for today. But if you like the content and what we're doing here at UXDX, we have some events coming up in May next year. So we'll be in New York in early May and Berlin late May. We'll have 40 speakers across product, UX design, and dev. So it's all about how we can bring teams together. So I hope you enjoyed this talk. Just want to thank Rustam once again for sharing, and I hope to see you next time. Thank you very much.